Hello students, in today's class I am going to begin a new topic called as inverse trigonometric functions. But before we could start today's chapter, let us summarize what we all know in a trigonometry. Yes, for a given right angled triangle, there exist 6 trigonometric functions. We all are familiar with it. They are called as sin x, cos x, tan x, and the 3 reciprocals cosec x, cot x and secant x. For this 6 right angle trigonometric functions, there exist even their inverse trigonometric functions also. Yes, so to study inverse trigonometric functions, let us move on. This inverse trigonometric functions was invented by Daniel Bernoulli, a Swiss mathematician. Not only he was a mathematician, even a renowned physicist also, where Bernoulli's principles are famous in our studies. So John Bernoulli invented inverse trigonometric functions. Now let us move on to our topic. Let us deal in detail what do we mean by inverse trigonometric functions. So for that, let us brief out our 6 trigonometric functions with their domains and codomains. What do we mean by first by domains? If a relay function is defined from set A to the set B, then the set A is called as domain and the set B is called as codomain, which we have already know this. So with that, we know sine function domain is set of real numbers, complete set of real numbers, whereas its codomain is a closed interval from -1 to +1. Remember students, it's a closed interval from -1 to +1. Moving on to the second trigonometric function called as cosine of the function. Usually we tell it as cos of the function, where once again the domain is set of real numbers itself and codomain is closed interval from -1 to +1. Tangent function, set of real numbers, but it is not complete set of real numbers, excluding odd multiples of pi by 2, excluding odd multiples of pi by 2, and its codomain is complete set of real numbers. Cotangent function, that is cot function, set of real numbers but excluding pi. Why should we exclude pi? If we include pi over there, it becomes what? Indeterminate form, because cot is the reciprocal of our tan function and its codomain is set of real numbers. This is our secant function and this is our cosecant function. So which you have already know, but you have to memorize it thoroughly. All the 6 trigonometric functions, their domain and codomain. With this, let us now move on to inverse of sine function. Already we know what is a sine function. With that connection, let us see what is inverse of a sine function. But students, let me clear one very good point here. For a given function, inverse exists only if it is a 1-1 function and onto function. What do you mean by 1-1 function, which you already know in the previous classes? 1-1 function means one element must be related to a single element. Then such type of a function is called as 1-1 function. I'll give you one simple example. For every student, there exists a unique register number, right? One student cannot have 2 register numbers. So one student has only one register number. Such type of a function is called as 1-1 function. Then moving on to onto function, there in the elements of the codomain, there not be any left out element in the codomain. Means what? All the students for an examination are present. No one is absent for the examination. Such type of a function, such type of an example is called as onto function. So for an inverse to exist, the function must be 1-1 function as well as onto function. Then only the inverse exist or it does not exist. Let us now move on to the first function, inverse of sine function. Since we all know that the domain of the sine function is set of real numbers and its codomain is -1 to +1. If we take it like this, the inverse does not exist because there will be overlapping. Once there is overlapping, the function is not one function. In order to make the sine function, in order to make its inverse exist, so we have to restrict the domain. Restrict the domain means I am going to restrict the domain, the set of real numbers, only to -π/2 to +π/2. Then only it becomes one function, and on to with range closed interval -1 to +1. So students, do remember thoroughly, the inverse function becomes 1 and onto only when we restrict its domain. So we have to restrict the domain to what? Closed interval -π/2 to +π/2, and its range will be closed interval -1 to +1. Then only the sine function becomes 1 and onto then only its inverse exists. So we have to define the sine inverse function as it is a function whose domain is, it gets reversed, you might be observing here, because it is inverse, its domain is closed interval -1 to +1 and its range is -π/2 to +π/2. So for example, if we have a question, define inverse of a sine function. How to define inverse of a sine function is whose range is, whose domain is closed interval from -1 to +1 and its range is -π/2 to +π/2. If we write only this much also, that is enough. And now with this definition, I am going to tell you two important points that will help us to solve the problems. The first point is, a student can write, we are permissible to write sine inverse of sine x is equal to x only if x lies between -π/2 to +π/2, only if x lies between -π/2 to and +π/2, and the vice versa you can observe here. What is the vice versa of it? Sine of sine inverse x is also equal to x provided x lies between -1 to +1. And this is very important point, students. The branch with the range closed interval -π/2 to +π/2 is called as principal value branch. It is called as what? Principal value branch. So the question might be, or you are supposed to remember it thoroughly, what is the principal value branch of sine inverse x? The principal value branch of sine inverse x is closed interval -π/2 to +π/2. I'll just repeat once again. Inverse of sine function exists only when sine is 1 and onto. How to make it as 1 and onto? I'm going to restrict its domain to only to what? Closed interval -π/2 to +π/2 and range to what? -1 to +1. Define inverse of sine function means how we are going to define? Inverse of sine function is defined as sine inverse from closed interval -1 to +1 to the closed interval -π/2 to +π/2. And two important points, sine of sine inverse x is equal to x. Sine of sine inverse x is equal to x, so where only when x lies between -1 to +1. Here sine and sine inverse we can remove and write it as only x. And the other way is very important point for the problems. Sine inverse of sine x is also equal to x, students. Sine inverse of sine x is also equal to x, but here what happens? X lies between -π/2 to +π/2. And what is the principal value branch of our sine inverse x function? It is nothing but closed interval -π/2 to +π/2. While solving the problems, the answer must lie only in the closed interval. Then only it is called as as principal value of sine inverse x. With the definition of sine inverse of x, now let us move on to its graph of sine inverse x. But before that, students, let us concentrate what we have already studied in the previous class, that is nothing but a sine x curve. Sine x curve is usually called as wave curve. Yes, you might be observing here, this is our sine x curve. Sine x curve passes through the origin. Why? Because sine of 0 is equal to 0. Sine of 0 is equal to 0, and it takes a curve, increasing curve here. Sine pi by 2 is 1. When x is pi by 2, the value is equal to 1. Then again sine pi is 0. So only it meets at our x-axis. It is sine x curve is an increasing and decreasing curve. With the sine x curve, now let us move on to its inverse curve, that is called as sine inverse of x. You might be observing it is been reversed over here because it is a inverse function. Y is equal to sine inverse x. Once again, the curve sine inverse x passes through the origin. The curve sine inverse x passes through the origin, and this is our sine inverse x curve. So the students must practice how to draw the sine inverse x curve. Let us now move on to the second inverse function called as inverse of cosine function, students. Cosine function is defined once again on set of real numbers, but in this set of real numbers, range is -1 to +1. We have to restrict the domain of the cosine function, isn't it? Why we have to restrict the domain of the cosine function? In order to make it as 1, 1 and on to. So how to restrict it? I will restrict it as to closed interval 0 to pi, then only the inverse of the cosine function exists. Then only it becomes 1, 1 and on to with range what? With the same range, closed interval -1 to +1. Now with this explanation, let us tend to define inverse of the cos function. So cos inverse x is a function defined from closed interval -1 to +1 and to the closed interval 0 to pi. I hope now you can guess which is the principal value branch of our cos inverse x. Yes, students, which is the principal value branch of our cos inverse x? It is nothing but the closed interval 0 to pi. So the first point is cos inverse x is defined from closed interval -1 to +1 to the closed interval 0, pi. This is important 1 mark definition. Define cos inverse of x function and whose principal value branch is closed interval 0, pi. This point must be remembered in order to solve the problems. With the definition of cos inverse x, now let us move on to the graph of cos inverse x. This is first the graph of cos x. You can observe here in the graph of cos x, once again it is a wave curve itself, but observe carefully, cos x does not pass through the origin. Why cos x graph does not pass through the origin? Because cos of 0 is not 0, but cos of 0 is equal to 1. So it touches the y-axis at the point 1. Cos of 0 is 1, but in a reverse way, cos of pi by 2 is 0. So then it comes down onto the x-axis. This cos x function is a curve, is once again increasing and decreasing function, students, which you have already learnt in your previous class. In the mind of cos x, let us move on to its inverse. Y is equal to cos inverse x. You might be observing the numbers have become reversed. The range is now -1 to +1. Once again it is a wave curve. Cos inverse x curve also does not pass through the origin. It does not pass through the origin. Cos inverse of pi by 2 is 0, so only the curve touches our y-axis. This is y equal to cos x graph, and this is y is equal to cos inverse x graph. Students must practice to draw cos inverse of x graph thoroughly. Now let us move on to the third inverse function called as inverse of the tangent function. Let us try now how to define the inverse of tangent function. We know that the domain of the tangent function is once again the set of real numbers itself, but not complete the set of real numbers, excluding r minus what? R minus the odd multiples of pi by 2. R minus 2n plus 1 stands for odd, 2n plus 1 into pi by 2, and the range is complete set of real numbers. So in order to make it as 1 and onto, why we have to make it as 1 and onto? So that its inverse exists, isn't it? So in order to make it as 1 and onto, I will barricade the domain as open interval minus pi by 2 to plus pi by 2. Observe here carefully, I have changed the closed interval to the open interval. Why did I do so? Because when I take up the closed interval, we are permissible to put pi by 2 into the function, and we all know that tan of pi by 2 is what? Undefined. Tan of pi by 2 is undefined. So observe carefully the intervals. I have changed the closed interval to the open interval. This denotes what? Open interval. Hope you understood why should we change the interval. When I take the closed interval, I will put tan x as tan pi by 2, and tan pi by 2 is undefined. So closed interval is changed to open interval, and range, there is no change. Range is what? Set of real number itself. So with this, what will be tan inverse? Just reverse this. Set of, now domain, this is for tan and this is for what? Tan inverse. Tan inverse is set of real numbers to open interval minus pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2, and hope now you can guess properly, because this is our third inverse function, isn't it? What is its principal value branch? The principal value branch is open interval minus pi by 2 to plus pi by 2. Two important points students must remember for the further problems. First question is define inverse of a tangent function. How do we define it? The inverse of a tangent function is defined as tan inverse from set of real numbers to the open interval. Open interval, once again I am pointing it out, it is open interval minus pi by 2 to plus pi by 2. And what will be its principal value branch? Of course, obviously, what will be its principal value branch? Minus pi by 2 to plus pi by 2 means principal value branch means there is the standard branch, standard values where the function, inverse function exists. While solving the problem, students, once again I am noting here, while solving the problems, the answer must lie only in this open interval minus pi by 2 to plus pi by 2. For what? For inverse of tangent function. So three inverse functions are over. Now let us concentrate on its graph. Graph of tan inverse x, yes sure, but before that just let us go back a little and summarize what we have studied about tan x function. This is not a wave curve, this is not a wave curve. It is just the curves that touches, that each curve passes through our x-axis, and it is unbounded on both sides. Why it is unbounded on both sides, students? Because we all know that tan of pi by 2 is undefined. It is infinity, so it is unbounded. But once again, tan x curve meets at the origin. Why does it meets at the origin? Because tan of 0 is equal to 0. Yes, tan of 0 is equal to 0, and pi is also 0. Pi by 2, then comes what? Minus pi, 3 pi by 2 and 2 pi. This is the curve of tan x. What about the curve of tan inverse x? How exactly it looks? Everything is reversed, it is interchanged, isn't it? Then tan inverse of 0 is also 0, so only the curve is passing through the origin, and tan of pi is also 0, tan of 2 pi is also 0. You might be observing I have drawn here dotted lines. What does this dotted lines implies? Whether it is tan x curve or tan inverse x curve, they are being excluded. Why should we exclude? According to our definition, r minus the odd multiples of pi by 2, isn't it? R minus the odd multiples of pi by 2. Whichever values are being excluded, I have just highlighted with the dotted lines, and these are the values which we can apply in our function, that is either tan x or either tan inverse x. So I have just done both. This is tan x and this is our tan inverse x. Now the next three will be what? Secant inverse x, cosecant inverse x and cot inverse x. The other next three are nothing but the reciprocals of the first three. So with that I have just prepared a table which gives us the complete picture of all the inverse trigonometric functions till now what we have studied. So sine inverse x, which I have told you in detail, its domain is -1, closed interval, right? Closed interval -1 to +1, and its range is -pi by 2 to +pi by 2. Range is also called as what? Principal value branch. What about cos inverse? This is the definition also. How to define cos inverse? Cos inverse is a function whose domain is closed interval -1 to +1 and its range is closed interval 0 to pi. Cosec inverse, it is r minus reciprocal of our sine inverse is cosec inverse. Cosec inverse is nothing but the reciprocal of sine inverse, but we are going to exclude -1 to +1. Why should we exclude? Because sine inverse is the reciprocal of cosec inverse. The function gets overlapped. Once the function gets overlapped, what it implies? It does not become one function. So it is r minus of minus open interval -1 to 1. Why I have considered open interval, students? Such that I am not permissible. We cannot substitute x as either -1 or +1, and its range remains the same, but be careful, minus the element 0. Why should I exclude 0? When I put 0, cosec inverse is nothing but the reciprocal of sine inverse. 1 by 0, we all know that it includes 2, it becomes what? Indefinite, undetermined. So the question can be framed like this for 1 mark. Find the or write the range of cosec inverse x. What's the range of cosec inverse x? Closed interval -pi by 2 to +pi by 2 minus the set 0. Students make mistakes, they forget of writing this set. You should not write. If you forget the writing set, what happens? It becomes sine inverse. Is it sine inverse? No, students, it is what? Cosec inverse. And if you write only -0 is also wrong. You should write 0 in a set, minus closed interval -pi by 2 to +pi by 2 minus the set containing the element 0. Secant inverse, reciprocal of our cos inverse, which we all know. Once again, r minus of -1 to +1. Same thing we take, but this time observe, I have not excluded 0, but I have excluded what? Pi by 2. Why? Because cos of pi by 2 is 0. Then secant is a reciprocal of cos, secant inverse also is a reciprocal of cos inverse, it's understood. And when I substitute pi by 2 in the denominator, it leads to what? Undefined, indeterminate form. So only 0 to pi closed interval minus the set containing pi by 2. What about tan inverse? Same, r to open interval, it is open interval, students, minus pi by 2 to +pi by 2. Cot inverse is r to open interval 0 to pi, reciprocal of tan inverse is our cot inverse. Students must really thoroughly memorize these tables, not only for the problem's sake, even for our 1 mark questions, even for 1 mark questions also. So now let us move on to few tricks before we could start today's class problems on basic problems on inverse trigonometric functions. What are that? I have just made a table so that it will be easy for you all to memorize and solve the problems quickly. We all know that sine of 0 is what, students? Sine of 0 is nothing but 0. So on the same basis, sine inverse of 0 is also 0. Here in trigonometry, the angles used to be inside and the real numbers used to be outside. But here, since it is inverse, reverse it. Sine inverse of 1 by 2 is pi by 6. I'll give you one more example. This third example, students. Sine of pi by 4 is 1 by root 2. Yes, sine of pi by 4 is 1 by root 2. Sine inverse of 1 by root 2 will be equal to what? Pi by 4. Sine inverse of root 3 by 2 will be equal to pi by 3, and sine inverse of 1 is pi by 2. Just concentrate on the last one. I'll just explain once again. We all know that sine of pi by 2 is 1. What does it imply? How can I write in the inverse form? When sine of pi by 2 is 1, sine inverse of 1 will be equal to pi by 2. I have just listed the formula of sine inverse. Now slowly let us think of the standard values for cos inverse. Cos of 1 is 0. Cos inverse of 0 will be equal to what? 1. Yes, cos inverse. After sine inverse column, now I will just take you people to cos inverse column. Observe, I have listed few standard values. Students must memorize these values thoroughly. Yes, before that let us think of cos, right? Before cos inverse, let us think of cos. Cos of 0 is what? Cos of 0 is 1. So just bring that cos to the either side, it will become what? Cos inverse, isn't it? Cos inverse of 0 is 1. Just try to apply this. Cos inverse of root 3 by 2 is pi by 6. Cos inverse of 1 by root 2 is pi by 4. Cos inverse of 1 by 2 is pi by 3, and cos inverse of 0 will be equal to what? 1. After that, I'll take you to the third column that depends on tan inverse, but tan of 0 is 0. Tan inverse of 0 also will be equal to 0. Very standard values to be memorized. Tan inverse of 1 by root 3, pi by 6. Tan inverse of 1, pi by 4. Observe this. Tan, if I shift this tan inverse to this side, it will become what tan is? Tan of pi by 4 is 1. Then reshift it. Tan inverse of 1 is what? Pi by 4. Tan inverse of root 3, pi by 3. Tan inverse of infinity is undefined, but here I am permissible to write equal to what? Pi by 2. Tan inverse of infinity is pi by 2. These are the three columns, standard inverse values to be thoroughly memorized by the students, and even I have explained how I obtained these values. How did I obtain? Using the sine, cos, tan, I have obtained sine inverse, cos inverse and tan inverse. Just I have listed a remark here, but before that we all know that sine of minus x is what? Minus sine x. Minus comes out whenever it is sine, right? So sine inverse of minus x also will be equal to minus sine inverse x. Cos inverse of minus x, pi minus cos inverse x. Tan inverse of minus x, as usual, minus tan inverse x. How I wrote this? Using our basic trigonometric properties. And not only this, these three properties also will be proved in the next classes. This have to be remembered by the students in order to solve the problems. Sine inverse of minus x is minus sine inverse x. Tan inverse of minus x is minus tan inverse of x. But observe, in case of cos inverse, it gets little different. Cos inverse of minus x is pi minus cos inverse of x. I have taken 1 mark questions, good questions on this. Even we can move for 2 marks as well as 3 marks. What is the question? Find the principal values of the following. Observe the word. We are not just finding any value, but what? Principal value only. Principal value means what? The obtained value must lie in the given range, in the range what I have showed in the table. First one, sine inverse of 1 by root 2. we are going to find this principal value. And not only this 1 by root 2 is a standard value for sine, so it implies even it is a standard value for sine inverse also. Just concentrate on the solution, students. Let us assume y equal to sine inverse of 1 by root 2. Sine inverse, when I shift from RHS to LHS, what it will become? Sine y. Sine y is equal to 1 by root 2. Observe this, sine y equal to 1 by root 2 is a standard trigonometric equation, we all know that. So what will be its principal value? Principal value is automatically pi by 4. Just substitute, let me check whether sine pi by 4 is 1 by root 2. Yes. Therefore, principal value is pi by 4. This can be asked in the question paper in the PU board for 1 mark. Find the principal value of sine inverse of 1 by root 2. Assume let y equal to sine inverse of 1 by root 2. Shift that sine inverse to this side, it will become sine y. Sine y equal to 1 by root 2. Therefore, the principal value is pi by 4. Observe the second question. Second question is also similar, but there is one very good minus sign. So, be careful with this minus sign, students. Let y equal to, as usual, sine inverse of minus 1 by 2. Sine inverse, I will shift it to LHS, it becomes what? Sine y, and that minus carries out, it remains as it is. Sine y is equal to minus 1 by 2. For a while, let us forget this minus and think it is only sine y equal to 1 by 2. When sine y is 1 by 2, what will be y equal to? That its value will be equal to what? Y will be equal to pi by 6. Since here minus is there, I have to carry out. It is not pi by 6, students, but it is what? Minus pi by 6. So, check whether minus pi by 6 lies in the closed interval minus pi by 2 to plus pi by 2. Yes, it very much lies. Minus 92 plus 90, and this is minus 30. It lies in that closed interval. With this, what can I conclude? The principal value is minus pi by 6. Do not forget this minus till the end of the solution. Move on to the third problem. Very standard it is. Have little changed the solution. I have taken the second type of solution. This is also an easy one. How to do it? Little more, still more directly in order to save our time. Third question, cos inverse of root 3 by 2. Root 3 by 2 with cos. Think like this. Root 3 by 2 with cos gives us which angle? It gives us pi by 6, means 30 degree. Cos inverse of root 3 by 2 can be rewritten as, I have maintained this cos inverse as it is, observe students, and in a bracket root 3 by 2 I have written it as pi by 6. Recheck. Cos pi by 6 is root 3 by 2. Yes or no? I will repeat the first step once again. Cos inverse of root 3 by 2 equal to cos inverse of, how to write root 3 by 2, students? Cos of pi by 6. And now I am permissible to eliminate this cos inverse and cos and write only the angle pi by 6. Why I can do that? How I can eliminate this cos inverse and cos, students? Because pi by 6 lies in the range. You all remember? According to that previous table of today's class, what is the principal value branch of our cos inverse? Closed interval 0 to pi. Means what? Closed interval 0 to 180. And this is our 30 degree. Surely 30 degree lies in the closed interval 0 to 180 degrees. So only cos inverse cos can be eliminated. Why it can be eliminated? Once again I am stressing on this point. It is eliminated only because pi by 6 lies in the principal value branch of cos inverse. What is the principal value branch of our cos inverse? Closed interval 0 to pi. So the final answer is pi by 6. Fourth question, cos inverse only it is, but I have included one minus sign. That inclusion of minus sign makes a good difference in our solution. Observe, concentrate how I am going to first exclude that minus sign. Cos inverse of minus x. What is the formula according to that remark? Cos inverse of minus x is pi minus cos inverse x. In this question, x is what? X is 1 by 2. pi minus cos inverse x. Pi minus cos inverse of x I have value, I have substituted it as pi 1 by 2. Pi minus cos inverse of 1 by 2, which is equal to pi, maintain it as it is, minus cos inverse of 1 by 2 is a standard value. Yes, that can be written as pi by 3. Yes, cos inverse of 1 by 2 is what? Pi by 3. Take the LCM. 3 into pi is 3 pi. 3 pi minus pi is 2 pi. 2 pi by 3. Cos inverse of minus 1 by 2, its principal value is 2 pi by 3. Just think, if it to be still more clear, 2 pi by 3 is nothing but 120 degree, and surely 120 degree lies in the closed interval 0 to 180. So only I have concluded its principal value is 2 pi by 3, students. Fifth important question, repeated many a times in our PU board paper for 1 mark, and the students must be really attentive with its minus sign. Tan inverse of minus 1 is minus tan inverse 1. Quickly recollect from where I got this minus sign. Tan inverse of minus x is minus tan inverse of x. Tan inverse of minus 1 is minus tan inverse of 1 minus tan inverse 1. I have replaced it as tan pi by 4 in a bracket. What is one value? Tan pi by 4, which we already know, minus carried out as it is. Tan inverse and tan cancels out. It gets eliminated. Why it gets eliminated? I am permissible to eliminate only when it lies in the principal value branch. So what's the final answer? Therefore, principal value is of the given expression is minus pi by 4. Now let us move on to the last problem of today's class. Cot inverse of minus 1 by root 3. This is a standard formula. Cot inverse is rewritten as pi minus, students must remember this, pi minus cot inverse of 1 by root 3. Pi minus, I have maintained it as it is. What is cot inverse of 1 by root 3 value? Pi by 3 according to that standard result. Take the LCM, the final answer is 2 pi by 3. So you might be observing 4th, 5th and 6th questions are little bit concentrative one because it includes minus sign, or else directly also you can keep on doing by remembering this standard table which is in front of you all. So in today's class you have come across 6 inverse trigonometric definitions, their domains, range and main important is principal value branch, and these are the problems. Thank you.